Set notation is slightly more annoying to use than interval notation, but can give us a little bit more flexibility. What's a set? Well, a set is just a collection of mathematical objects. For you and me, that usually means real numbers. Here's what a set looks like. We use these curly brackets. This is the set X, and it's equal to 0, 1, 2, 3, 4, and 5. Those are all the elements of the set, just those 6 numbers, and we surround them with curly brackets. Suppose you had a set with nothing in it. Well, creatively enough, we can just use a curly bracket with nothing in it. Here are some very common sets you might be familiar with. First, we have the natural numbers. It's denoted with this character n. It's the counting numbers starting at 1. 1, 2, 3, 4, 5, up forever in that fashion. We have the whole numbers, which are just the natural numbers, but we also include 0. Z are the integers. Those are all the counting numbers, including 0 and the negatives. So we have 0, 1, 2, 3, 4, 5 up forever. We also have -1, -2, -3 down forever. Q is the rational numbers. These are all fractions. These are integers over integers. And of course, we can't divide by 0. Notice the set notation here. This is where set notation gets a little bit confusing. Set notation here is X. So that's what's in the set. It's a number. And next to the X is this vertical line. This is the condition of something being in the set. So this says Q is any number given or such that that number is a fraction, or that number has a form A over B. This is why set notation can be slightly tricky, but we can describe a lot of things. Here we have the irrational numbers. These are things like square root of 2 or pi, things that cannot be written as a fraction and have an infinite decimal representation. They are numbers that cannot be written as a fraction. And then of course we have the real numbers, which is the main focus of calculus. The real numbers are the rational numbers union the irrational numbers. You have all the rational numbers, put them together with the irrational numbers, and we have the real numbers. Now we can describe intervals using set notation like this. Here we have that interval -5 to 1 in brackets. That means -5 and 1 are included in our set. We can say our interval contains numbers which are real numbers given that they lie in this interval -5 less than or equal to x is less than or equal to 1. So again, a slightly more confusing way to describe something, but it's completely equivalent to writing bracket -5 to 1 bracket. We can do a very similar thing when we don't include the endpoints. Say we have the same interval, but we're excluding those endpoints. We'll use a very similar set notation. Any real number who lies between -5 and 1 without those or equal to signs. This set notation is exactly the same thing as saying -5 to 1 in parentheses. That's how we can use set notation for intervals.
Hey guys, my name is Jess, the head of education here at Wise. I hope you enjoyed this video tutorial. If you want to see the complete course, please check out the link in the description. You can also go to one of our playlists to keep learning for free. If you want us to cover a specific course or a specific topic, please leave us a comment below. We post new videos every week, so don't forget to subscribe so you don't miss out on any of the new stuff.